Hello everyone, I'm Adnan Mukhtar. Today we will be discussing how to find eigenvalues and their corresponding eigenvectors. So we will consider for both cases, that's for 2 cross 2 matrix as well as for 3 cross 3 matrix. Okay, so we will start with our lecture with 2 cross 2 matrix. We will find its eigenvalues and their corresponding eigenvectors. So now let us consider a vector, 2 cross 2 vector, matrix. So we have a matrix A is equal to 4 by 3 and 1 2. So how will we find its eigenvalues? First we will find it as characteristic equation. What is it? Is characteristic equation. So its characteristic equation is lambda I minus a determinant of lambda I minus a into x is equal to 0. Okay, where lambda are the eigenvalues of the matrix, I is the identity matrix and A is the matrix given, and this X is the eigenvector. We can also write it as for 2 cross 2 matrix it will be x1 x2, and for 3 cross 3 matrix it is x1 x2 and x3. Since we have considered 2 cross 2 matrix, okay, now let's start how to find the eigenvalues of this given matrix. So first of all we will find its eigenvalues by using this characteristic equation. Okay, we know if we multiply lambda to an identity matrix what we will get. Okay, since we have 2 cross 2 matrix, our identity matrix will also be 2 cross 2, so it will come out like to be lambda 0 0 lambda. Okay, now minus a, sorry, A is our given matrix 4 3 1 2. It's just determinant. So I hope you know how to do subtraction of two matrices. So lambda minus 4 minus 1 minus 3 lambda minus 2 is equal to 0. Now for a 2 cross 2 matrix, you know how to find its determinant. Let's do that. So lambda minus 4 into lambda minus 2 minus 3 into 1, that is 3, is equal to 0. So lambda square minus 4 lambda minus 2 lambda minus 8, sorry, plus 8 minus 3 is equal to 0. So lambda square minus 6 lambda plus 5 is equal to 0. So this is our characteristic equation. Okay, so you can solve it either by using discriminant rule or middle subgroup method. Whatever you want to use, just we have to find its values, the values of lambda, which are the eigen values. Okay, so the eigenvalues will be, if we solve it by using this method, that is d is equal to b square, that is 36 minus 4ac, that's 20, so it is 16. So lambda is equal to minus b, minus minus is plus, plus minus under root of 16 by 2a, and a is 1, that is 2. So lambda is equal 6 plus minus 4 upon 2, so 10 upon 2, 2 upon 2. So eigenvalues are 1 and 5. So these are our eigenvalues for a 2 cross 2 matrix that we have considered. Okay, now we have two eigenvalues, that is 1 and 5. Now for each eigenvalue we will find its corresponding eigenvector. So first we will find an eigenvector for the eigenvalue 1, then 5. So let's find the eigenvector for the eigen value 1. So we have lambda is equal to 1. So our equation in the form of matrix is lambda minus 4 minus 3 minus 1 lambda minus 2 into x is equal to 0. So lambda minus 4 minus 3 minus 1 lambda minus 2, we'll write x as x1 x2 is equal to 0. So we'll substitute the value of lambda, that is 1, in this. So 1 minus 4 minus 3 minus 1 minus 2 into x1 x2 is equal 0. So it comes out to be minus 3, minus 3, minus 1, minus 1, x1, x2. Now in order to find the eigenvector, we can choose any of these equations. So if you have a 2 cross 2 matrix, then you can choose any of the equations. Like we will choose the first equation. Now if we have a 3 cross 3 matrix, we have to choose 2 equations, and you can choose any 2 equations of your choice. So we will choose the first equation. So the first equation will be minus 3x1 minus x2 is equal 0. So we will transpose the terms. Minus x1 is equal to x2. So x1 will be x2 upon minus 3. So our eigenvalues will be, I have x1, x2 is equal to 1 minus 3. Whatever is under the denominator of x1 and x2, these are our eigenvectors. Like we have 1 as denominator for x1, x1 is the numerator, and minus 3 as denominator, and x2 is the numerator. So 1 and minus 3 are the eigenvalues. Here you can also do another thing, like what we did here, we transposed x2. We can also transpose x1. Minus 3x1 minus x2 is equal to 0. We can transpose x1 there. That is minus 3x1. So minus 1 goes. Sorry, this is x1, this is x2. So that is x1. Now x2 divided by 3. Sorry. When we transpose 3x1 on the RHS, it will be positive. Okay. So this is minus x2 is equal to 3x1. So x2 divided by 3 is equal to x1 divided by minus 1. So x1, x2 will be minus 1, 3. So both answers are correct. You can do any one of these. Okay. So the method should be clear. Okay, both answers are correct. You can also write 1 minus 3 minus 1 or 3. You can also write here, like we had minus 3x1, we will keep minus 1 here, so it will be minus 1, it will be 3. It's okay, nothing to worry about. Now we will consider the second eigenvalue, lambda is equal to 5. So we will find the corresponding eigenvector for this eigenvalue. So lambda minus 4 minus 3 minus 1 lambda minus 2 into x1 x2 is equal to 0. So we'll substitute the value of lambda. 5 minus 4 minus 3 minus 1 5 minus 2 x1 x2 is equal to 0. So you can choose any of the equations of your choice. That is 1 minus 3 minus 1 3 x1 x2. You can choose any equation. So we'll choose the first one. So the first equation is one x1 minus x2. So the first equation is x1 minus x2 is equal to 0. You can transpose x2 over here. So denominators have 1. So x1 x2 will come out as 1 1. So this is the corresponding eigenvector for the eigenvalue 5. So I hope it is clear that how to find the eigenvalues and their corresponding eigenvectors for a 2 cross 2 matrix. Now we will consider the same case for 3 cross 3 matrix. We'll check how to find the eigenvalues and eigenvectors for a 3 cross 3 matrix. But before we solve this, we have to remember we are going to use a rule, that is Cramer's rule. I hope you have gone through that in your previous classes. We will use that for a 3 cross 3 matrix, and we can easily calculate our eigenvectors. This rule is very easy. Just remember what I'm going to do. Okay, now we will consider our second matrix, that is a 3 cross 3 matrix. A is equal to 8, 4, 3, minus 8, minus 3, minus 4, minus 2, minus 2, and 1. So in the same manner, we will first find its eigenvalues, then its corresponding eigenvector. So let's start with this characteristic equation, that is lambda I minus a into x is equal 0. Now here x is x1, x2, x3, x factor. Okay, so lambda is, it will come out to be like 0, 0, 0, lambda 0, 0, 0, lambda minus a. A is our given matrix. 8, 4, 3, minus 8, minus 3, minus 4, minus 2, minus 2, 1. We have to find this determinant. Okay, now first we will do the subtraction. So lambda minus 8, 8, 2, minus 4, lambda plus 3, 2, minus 3, 4, lambda minus 1. So this is our matrix. Now we will find it as determinant. I hope you know how to find the determinant of a 3 cross 3 matrix. So lambda minus 8 into lambda plus 3 into lambda minus 1 minus 8 into minus 4 into lambda minus 1 sorry we'll write it again. Lambda minus 8 into lambda plus 3 into lambda minus 1 minus 3 into 2. Now the second term, minus 8 into minus 4 into lambda minus 1 into, you will hide this and this column and first row. So what we are left with, minus 4 into lambda minus 1 minus 3 into 2. Now we will hide this and this. What is left? Minus 4 lambda plus 3. So 2 into minus 4 into 4 into minus 3 into lambda plus 3. So I hope you know how to solve this equation and you will get the eigenvalues. So the eigenvalues are 1, 2, and 3. So these are our eigenvalues for the matrix we have considered. Okay, so our eigenvalues are 1, 2, and 3. Now one by one we will find their corresponding eigenvectors. Okay, so first we will solve it for 1, then 2, then 3. Okay, now first we will choose first lambda is equal to 1. This is our first case. Okay, now lambda minus 8 minus 4 minus 3 8 lambda plus 3 4 2 2 lambda minus 1 into eigenvector x1 x2 x3 is equal 0. So we'll substitute the value of lambda as 1. So it's minus 7 minus 4 minus 3 8 4 4 2 2 0 x1 x2 x3. So at the start I told you that for a 2 cross 2 matrix we will consider only one equation of your choice. Now here we have 3 cross 3 matrix, we will consider 2 equations of any choice of our choice. Okay, or you can consider any 2 equations of your choice. So we will consider first 2 equations. So the equations will be minus 7 x1 plus 8 x2 plus 2 x3 is equal 0. The second equation 4 x1 my plus 4x2 plus twice x3 is equal to 0. Now here the twist is we are going to use Cramer's rule for solving these equations in order to find the solution of these equations. Okay, so for using Cramer's rule, so what we have to do here, just you have to remember, we consider x1 is equal to minus x2 is equal to x3. So first x1 you have considered positive, then x2 is called negative, and x3 positive. Upon for x1, x2 and x3 you have to also find their denominators. I will show you how. For x1, how you will find this denominator? What you have to do, you have to hide x1 in both the equations. So we will hide like this. So what we are left with, 8x2 plus 2x3 and 4x2 to x3. We will find the determinant. Okay, so x1, the determinant under x1 will be 8 into 2, that is 16, minus this is x2, and 4 into 2, that is 8. Similarly for x2, we will hide x2 in both the cases. So we have minus 7x1 plus twice x3 minus 4x1 plus twice x3. So the determinant will be minus 7 into 2, that is minus 14, plus 4 into 2, that is 8. Now for x3 we will hide x3. So what we are left with, minus 7x1 plus 8x2 minus 4x1 plus 4x2. So its determinant will be minus 7 into 4, that is minus 28, minus plus 4 is 32. Okay, now x1 upon 16 minus 8 is 8, minus x2 upon 14 plus 8, that is minus 6, is equal to x3 upon 28 minus 28 plus 32, that is 4. Okay, so minus goes, x1 upon 8 is equal to x2 upon 6 is equal to x3 upon 4. So the elements in the denominator, that is of x1, x2 and x3, are our eigenvectors. So we can write it as here x1, x2, x3 is equal to 8, 6, 4. You can also take 2 as common and you can write it as 4, that is 2 4s are 8, 2 3s are 6, 2 4s are 8, 2 3s are 6, 2 2s are 4. So this is also correct. So this is the corresponding eigenvector for the eigenvalue we have considered lambda is equal to 1. Similarly we will solve for lambda is equal to 2 and lambda is equal to 3. Same method. Okay, it's quite easy. So for lambda is equal to 2, now we have to consider case second, that is for lambda is equal to 2. Now I will directly substitute the value of lambda and will find the value of this matrix. Okay, the matrix will come out as x1, x2, x3. You have to substitute the value and do the calculations. It's easy. I will substitute the value of lambda as 2. 2 minus 8 is minus 6. Minus 4 minus 3. 8. 2 plus 4 comes out to be 6. Then 4. 2, 2. Lambda minus 1, that is 2 minus 1 is 1. Now we will find the eigenvector for this. So we will consider any two equations of your choice. We'll consider first 2, minus 6x1 plus 8x2 plus 2x3 is equal to 0. Similarly, minus 4x1 plus 6x2 plus 2x3 is equal to 0. We'll do the same method, use the same method, Cramer's rule. So x1 is equal to minus x2 is equal to x3 upon, you have to find the determinant. So for x1 we will hide the elements, both elements. So the determinant will be 8 into 2, that is 16 minus 12. So for x2 we'll hide this, and the determinant will be minus 6 2s are 12 plus 8 minus 12 plus 8. Now for x3 we'll hide this, so we are left with is visible, so minus 36 plus 32. Okay, so x1 upon 16 minus 12 is 4, minus x2 upon minus 4 is equal to x3 upon, so I think here I have done some mistake. Okay, no worries. It is minus 4. Okay, so minus minus goes, so x1 upon 4 is equal to x2 upon 4 is equal to x3 upon 4 minus 4. So you can take 2 as common, so it will be 2 2 3, that is minus 2. So our eigenvector is 1 1 minus 1. I hope this is clear. This was quite easy.